The topic for today's video is acceleration of free fall. In this topic, let me first make it clear that the value of gravitational acceleration or gravitational field strength, I have taken it as 10 meters per second square or 10 Newton per kg for easy calculation, right? Consider an object that is of 10 kilogram. So if the object is of 10 kilogram, its weight will be 100 Newton by W is equal to mg, where W is equal to 10 kilogram multiplied by 10 meters per second square gravitational acceleration. So its weight is equal to 100 Newton. The air resistance acting on the object is 0 because this is the condition in which we are dropping the object without air. Resultant force acting on the object will be 100 Newton because this is the only force that is acting on the object, and since there is no force opposing this force, weight force, so 100 Newton is actually the resultant force. By the formula F is equal to ma, Newton's second law, we can find out its acceleration. A is equal to F upon m. 100 divided by 10 gives 10 meters per second square, which means this is the acceleration just after you drop the object. According to this acceleration, after 1 second, the object will gain speed of 10 meters per second because the acceleration actually tells you how much change in velocity will be per unit time. So after 1 second, it will have a velocity of 10 meters per second. There will be no change to its weight, and there will be no change to air resistance, so there will be no change to resultant force, and hence no change to acceleration. So concluding this, the object will have the same acceleration throughout its motion, which will be 10 meters per second square, or you can say after every second there will be rise in velocity of 10 meters per second for the object. So the graph will be straight line through origin. Constant gradient means constant acceleration. And also, if you drop two objects of different masses, let's say this object is of 10 kg, the other object is of 100 kg, and you drop two objects from the same point, both will hit the ground at the same time because there will be no air resistance affecting the motion. So the acceleration affecting the motion for the two objects will be same, whether the object is lighter or heavier. Now, moving on to two objects of different masses will have no effect on their motion because there is no air resistance present, so the acceleration of free fall for them will be same throughout the motion. Acceleration of free fall in the presence of air, which means air resistance now will affect the motion. Initial condition of this case is same because when the object is not moving, there is no air resistance acting on the object, so the resultant force will be same and acceleration is 10 meters per second square. After first second of fall, it will gain about 10 meters per second of velocity, and since there is increase in velocity, there will be increase in air resistance as well. The value of air resistance is you can say I've just taken it, you can take any value for the understanding. I've taken 20 Newton right now. So according to the resultant force calculation, 100 Newton is the force acting downward, while 20 Newton is the force which is air resistance acting upwards. So resultant force is 80 Newton and acceleration is now 8 meters per second square. As you can see by this calculation that the acceleration of the object is now less than the previous acceleration. So the object will have increase in speed, but this time the increase in speed will not be 10 meters per second, it will be 8 meters per second. So at the second of the fall, the object will have 18 meters per second, which means 8 meters per second more than 10 meters per second. Due to increase in speed, there is increase in air resistance as well. Air resistance was 20, now it is 50, so acceleration will be 5 meters per second square according to the calculation. Now the object is accelerating, but the magnitude of acceleration is less than the previous one, so the increase in velocity will also be less than previous one. At this time the increase in velocity is 5 meters per second, and Due to increase in velocity, air resistance is also more, which is 80 Newton right now. So acceleration is 20 divided by 10, because resultant force is 20. There is acceleration but less than the previous one. There will be increase in speed but less than the previous one. At this case, let's say the air resistance is 100 Newton. Now the forces acting upwards and the forces acting downwards are the same, so resultant force will be 0. If there is no resultant force, there will be no acceleration, which means the object will now not change its velocity. The velocity the object has gained will be same throughout the motion remaining, and that speed, which is maximum possible speed for an object, is actually called terminal velocity. And as you can see, the acceleration is decreasing throughout the motion of the object. Now if you want to make the graph of this, the graph will be decreasing gradient graph, because the velocity time graph gradient is actually acceleration. Since acceleration is decreasing by the time, so the gradient is decreasing by the time. At this point the gradient is 0, which means acceleration is 0, and that constant velocity is called terminal velocity. If you want to define terminal velocity, you can write it is a maximum velocity of a free falling object when its weight and the air resistance are equal, and there is no resultant force acting on the object, and there is no acceleration produced. That's it for the concept. This video is actually for the students of O levels and A levels. Keep in mind that the value of gravitational acceleration is 9.81 for the students of AS. I have taken it as 10 because taking gravitational field strength 10 makes the calculation easy. So just to give you a clear concept, I have taken G as 10 Newton per kg, but actually it is 9.81 Newton per kg. Thanks for watching the video. Please subscribe. Air resistance is affecting the motion of feather more as compared to the ball, because the ball is heavier than feather, as you can see in this video.